Hello, everyone. Today, I'm gonna talk about a very interesting topic and very important topic in the machine learning, which is called the multimodality or multimodal machine learning in the medical science. I am Said Farzi. I am a senior AI researcher at Fandesino Bruno Learning in Italy, working on the European Horizon project called DREAM uh, in order to developing the multimodal and multilingual medical large language model. Okay, let's go. I'm gonna let in this slide. Let me share with you what I'm gonna talk about. What topics I'm gonna talk about. AI role in the healthcare, very important. We know that today's AI is playing a crucial role in the healthcare. I'm gonna talk about the importance of the AI in the healthcare nowadays. And next, move to the data modality. We know that in the healthcare we have a variety of the data, different modality, different type of the data, different format. Of course, brings lots of challenge to the machine learning projects. So in this video, I'm gonna talk about the data modality. In the next video, we go for a fusion methods, different techniques. We explore different techniques. Early fusion, intermediate fusion, late fusion, and mixed fusion. We're gonna explain, explain the method, talking about the pros and cons and applications. At the end, I will give you some examples in the about the role of the AI in the healthcare. Let's go further and dive into the healthcare landscape. This diagram helps me to explain demonstrate the application of AI in the healthcare. I categorize the application of the AI into the three categories: administrative, clinical, which is very important, and drug. Administrative area is consisting of the lots of the interesting projects like medical record management, patient scheduling, workflow optimization. Very, very important. The majority of the data type and data modality here, it's tabular data and the text data. In another group class is a clinical. The clinical class is also grouped into the four different subclasses. The first one is the diagnostic tools. This is prediction. It's very famous, this application. Predictive analytic, prognosis prediction, patient outcome forecasting for hospitals, risk management, personalized treatment. No, this is very famous. Treatment recommendation, dosage optimization. And the last subclass, but not the least, of course, it's about the image and biosignal analysis. Anomaly detection in images, image segmentation. You have a different kind of the images. ECG, EEG, time series signals, captured from the heart activity, captured from the brain activity. Vital signs, monitoring, such as blood pressures and heart rate variability. It's very useful in the sleep medicine. Maybe this kind of the information is captured from the wearable devices nowadays. The last subclass is about the drug and the application of AI in the drug category contains screening, target identification, drug optimization, drug design, adverse effect prediction. You can see we have a different area, different topics, different projects which can highlight the role of the AI in the healthcare. Okay, I in this slide uh, I try to give you some insight about the vast and variety of the application of AI. We do know that the AI and machine learning have already transformed the various industry, finance, game this industry, and of course healthcare. But in the healthcare, this adaptation is a little bit slow due to some challenges. The first one is coming from the data complexity, interpretability, and regularity constraint. Let me talk about it one by one. Data complexity, it's about the variety of the data, large volume of the data. You know that we in the healthcare domain, we should deal with the large volume of the images, CT scan images, capturing from the one organ of the human body. Complexity, quality, and consistency. Interpretability is very, very important. We need the explainable AI technique to cope with this problem. Trust and clinical validation and safety are very, very important. And regulatory constraint. We know there are lots of regularities in the countries, in the continent, like European Union. For example, GDPR, talking about the regulatory, how to use the data, how to um, protect the privacy, protect the private information of the patients. I'm not uh, gonna talk about the regularity constraint. In these slides, I'm gonna focus on the data complexity and multimodality. Let me ask you a question. Why multimodal learning is crucial for healthcare? This is very important. How a physician investigate a patient is very important because the AI model should replicate a doctor, a physician to make an informed decision. A doctor, when visit a patient, he or she try to study demographic information, lab test results, imaging, and medical history of the patients. All this data all together at the same time help him make an informed decision, diagnose the decision, prescribe drugs, and that sort of things. Of course, AI model must integrate all of this data, multimodal data, to better replicate the clinical reasoning. This is the importance of the multimodality in the decision and medical decision making. Okay, let's dive deeper. Let me show you the pipeline of the multimodal machine learning in the healthcare. This picture gives you a big picture of this project. At the left-hand side, we have a patient with the different data, omic data, imaging studies, lab results, medical records, vital signs, and variable devices informations. I categorize this kind of data into the four general categories: image, text, time series, and tabular data. It demonstrates this part demonstrates the data modality, different data type. Of course, all of them at the same time should be fed into the multimodal model. We need alignment, we need a fusion technique in order to handle this variety. The output is prediction, disease prognosis, hospitalization prediction, treatment outcomes, study and analysis, public health prediction, and blah, 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 etc., etc. Okay. We are close to the talking about the data type. Of course, different papers, different scientists came up with a different taxonomy. You can, for example, you can see here this information extracted from this paper, which is published in 2025. Categorize the data in the healthcare into the 4 categories. But from my point of view, data modality in the healthcare should be categorized in the 6 categories. You can see here, this diagram helps me explain in details each categories: image, text, time series, tabular, graph, and video. In image, we have a X-ray, CT scan images, MRI, PET scan, ultrasound. In the text, clinical note, clinical narrative, discharge note, radiology report, referral letter, different scientific paper, time series data, ECG, EEG, vital signs, tabular data, demographic, lab test, graph, of course, molecular information. It would be very useful in the drug discovery. Video, endoscopy, colonoscopy, provide you with a video, and the doctor need to study this video, look at the video very precisely in order to diagnose the diseases. Okay, I will give you some example from the MRI scan. You can see each image provide the different information in a different format, in a different shape. Of course, you need a different technique. We cannot use the same technique for all of them. For example, here is an MRI scan from brain, spinal cord. The resolution is very good. PET scan, different information. For example, this PET scan is captured from the brain. The normal brain should be shown like this. Mild cognitive impairment or Alzheimer's disease. Different technique. Ultrasound. You can see here. All together, X-ray. Here in this slide, I want to show you the different imaging technique, demonstrate the different information with the different resolution. You can see that all these pictures are captured from the brain. You can see here from, for example, X-ray, MRI, PET scan, MRI, CT scan, and other. Or different videos. For example, endoscopy. Let's play this video and show you.
An endoscopy is a procedure used to visually examine your upper digestive system. During an endoscopy, your doctor gently inserts a long, flexible tube, or endoscope, into your mouth, down your throat, and into your esophagus. A fiber optic endoscope has a light and tiny camera at the end. Your doctor can use this device to view your esophagus, stomach, and the beginning of your small intestine. The images are viewed on a video monitor in the exam room. If your doctor sees anything unusual, such as polyps or cancer, he or she passes special surgical tools through the endoscope to remove tissue or collect a sample to examine it more closely.
Okay, another video is about sonography video. Okay, let me show you the EEG and ECG now. As you see here, the EEG and ECG signal captured from the different leads. For example, for EEG, for ECG, the heart activity is modeled by the time series signal, which is captured from the at least 12 leads. But if you want, if you use the variable devices, something like the smartwatch, we just use the one lead. Of course, each lead provided different information. The same for EEG signals. Here, I'm gonna dive deeper, going to the file format. For example, for images, the icon, JPG and PNG. For text, PDF, JSON, XML, time series, CSV, Excel file, or relational databases. For tabular data, the same. GraphML, XML, and JSON. For video, MPEG-4, AVI, and other formats. Okay, I want to say that another thing that increase the complexity of the working in the healthcare, it's about the format of the file and format of the data. Different challenges coming from the different modality. For example, for image, large volume of the image, data interpretation is a little bit difficult. Computational costs, you need a very strong computational resources. Text, unstructured, ambiguity, multilinguality, privacy concern, anonymization, and that sort of things. Time series, large volume of data, noise, time synchronization, missing value. You should, you must deal with these problems when you uh, willing to work with the time series data. Tabular data, missing value, imbalanced data, high dimensionality. Remember the curse of the dimensionality in machine learning? Graph, data complexity, interpretability, data integration for video, large volume, data complexity, interpretability, alignment is very, very crucial in this regard. Okay, today I was gonna explain the data modality in the healthcare. You already know that we have a different data modality coming in a different format and coming up and rising the different challenges. How do we handle this kind of complexity? This is a very important question. I'm gonna answer this question in the next video. Have a good time. Take care.